very much. My name is Mujahid Chalta. A minute ago, I was your fellow student, but now I'm your teacher. So please listen carefully. Don't take notes unless you have to. So today's very first question I have for you is, what was the most amazing invention of last century, 20th century? Yeah? Okay, any other guess? Computer. No, internet works on computer. So computer was the most amazing invention of last century. In the coming century, or in the current century, we will reach new heights in technology, which may endanger our very existence. Any guess from this country?
The artificial intelligence.
Exactly. You said artificial intelligence. So AI might endanger our existence. And machine learning is the basis of artificial intelligence. About 7-8 years back, I was teaching a course on functional genomics, 2-day crash course. 60 people in the room, mostly teachers or cancer researchers or doctors. And when I was going through the course content, there was a line saying machine learning. And 2 people objected to that. They said, machines cannot learn. So you will see in the course, I have about half an hour for machine learning. No, it's all lie. Machines cannot learn. So I tell them, yeah, machines can learn, and we will prove it today in the last 5 minutes. So you will see how we can make machines learn. So today's learning objectives are how we can make machines learn. Right? It's a very simple example. There you go. Give them a book and they will learn. So this is a joke. But they will learn that this way. I assume we are computer scientists, we know what machine is. Anybody wants to take a definition of machine?
Collection of hardware.
Exactly, yeah. What is a simple machine? Floor is a simple machine. My grade 4s are always telling me. And computer is a machine, but a little complex machine. Let's start with basics. Line with direction. What is line with direction? Oh, very good, vector. And we have 2 lines with direction, 2 vectors. Can a machine learn or calculate the distance between these 2 vectors? Not learn, calculate. Can a machine do that? No. Can anybody disagree? No. So if we give the coordinate system and we can calculate the distance between 2 vectors using, what is that on the red box? Pythagorean theorem, right? Everybody in our class should know that. And if that vector is high dimensional, that was example in 2 dimensions, x and y. If it was in high dimensional, Pythagorean theorem is written just like this. But this is all in Euclidean space, x, y coordinates. There are some other spaces too. This is Euclidean distance. Any other distance measures you know of, which can calculate the distance between vectors? Manhattan. Any other? Manhattan correlation. This is correlation, for example. These 2 guys are correlated very well, these are not. And Manhattan, which calculates the distance between, how far they are, useful words. Very good. So, now think of these 2 dots as high-dimensional vectors, and let's personalize it. For example, I have 30,000 genes in my body. If I take my DNA and make a 30-dimensional vector, it can be represented as vector 1, right? And if I take 2 samples, one from a normal patient and other from a cancerous patient, and these both are 30-dimensional vectors, and if I have a data set, as you see on the screen, I can very easily see there are 2 probes. But our task today is what? How can machines learn to do that? And I'm going to teach you next less than a minute how we can make a machine to learn this. We can initialize 2 random points in this space, can we? Okay. Now, can I ask machine to calculate the distance from one point to other points? Machine can do that, right? Then I ask the machine to do the same for the second point. Okay? When that is done, I calculate a simple arithmetic mean of the points which are closer to number 1 and do the same which are closer to number 2. The machine can do that, right? And when that's done, I can ask the machine to shift these 2 points to the centers, to the means. And I iterate that few times. You can see the means shifted, and a time will come that there is not enough change in these means. They are not shifting. So the machine has now learned that there are 2 groups in this data set. And if a new client comes in, machine can very easily classify this into 2 groups. So my question back to you. Did we make the machines learn? Raise of hands.
Supervised.
Okay, yeah, we made simple case, very simple case. It can be more complex, but yes, we make machines learn. Can it be dangerous? Very subjective. Can it be dangerous?
Yes.
Yeah. Yes or no? Both are right. Imagine a century from now, a law is passed that anybody with a virus doesn't need to live, and something like this can carry out the law. Very dangerous law. But there are other advantages too. Again, coming back, what we learned today, what was the main learning objective today? We made machines learn. And we learned, this is again the same thing, that we make machines learn. And it can be dangerous. Think about it. We'll talk more about it in the next classes. Thank you.